So let's take a look.
By 75%.
F of 0, so f of 0 is equal to 5 times 0.75 to the 0 here, 0 there. What's any number to the 0 power?
1.
1. So that just becomes 5 times 1, which is just 5. Good? So what does that mean? That means that initially, right, at 0 weeks, so in other words, initially, to start with, does anyone understand what I'm saying? Initially, the initial amount is your starting amount. We had 5,000. Okay, I was like, can't have 5 bacteria. Okay, thank you. 5,000. I knew something. Bacteria.
That's what we're figuring out.
Okay. Evaluate f of 2. So let's do f of 2 together. All right, so f of 2 is 5 times 0.75 to the second, right? If I put in 2 here, 2 there. So we're going to do 0.75 raised to the second power. Has anyone done that already?
I did it.
Okay, I'll do it here. .75 raised to the second power, and then I'm going to multiply that by 5, and we'll get 2.8125, or maybe 2.82. You can round it there, maybe. So we'll say after
2.81.
2 weeks, 815. Oh, 8125. You're right.
Yeah.
81. My bad. 81. After 2 weeks, there are 2.81 thousand bacteria. We have less. They're decreasing. That's decay. So if I were to graph this, this is 5 times 0.75 to the x. Oh. Time. There we go. Times 0.75 to the x. There we go. Then we'd see. Wow, that's not right. There we go. You would see, start off with 5,000, but then as time goes on, each week we have less and less. So at 10 weeks we have like 0.0282. We have less and less. Make sense? Good?
Yeah, it's going down.
Yeah, it's going down. So if we kind of look at these, if we look at f of 2 and f of 3, so let's take a look at, you know f of 2, right? So let's look at f of 3. F of 3 is, right here, 2.109. Everyone see that? 2.109. Everyone write it down.
Round up to 2.11.
Yeah, 2.11. Yeah, 2.11 is good. That's fine.
Oh, and this is where you just divide them, this
Yep.
divided by the 2.81. 2.109.
It would be 2.81, but that's like 2.01. Well,
Yeah, so we're looking at 2.109, the f of 3 divided by f of 2, which was 2. What was it?
8125.
8135, 881. Yeah, you can put all the decimals if you like. And what do you think you're going to get?
0.75.
0.75, yeah.
Oh, because you're always getting back to the original, like, or something, is that why?
Right.
Like with the zero? So it's the same thing?
I get 0.749986, so 0.75 if I round.
Yeah.
All right, so then we'll take a look at the next one, which is f of 4. F of 4 is, can everyone see it? 1.582. 1.582. F of 4 is 1.582. So we're going to do 1.582 divided by 2.109. And again, you better get 0.75 or there's big trouble. Let's see.
The decimals are like slightly off,
Yeah.
like the last one I got 0.7509, this one I got 0.7488, that's
Yeah.
because you rounded it.
If you round to 2 decimal places or 3 decimal places, you'll get 0.75.
0.75, I think it's pretty much the same.
Yeah.
If you carry it out real fast, you're gonna get.
So what we're realizing is that when exponential decay occurs, we decrease by a fixed percent each time, right? In other words, we only had 75% of what we had before. We lost 25%. Does everyone see what I'm saying here? Yes? No? Okay, so each time we only had 75% of what we had before, so we lost 25%. That's my decay factor. So I have 100%, I subtract off 25%, I only have 75% left, so I'm decreasing by 25% each time. So my decay rate, the amount I lose is 25%. My decay factor, the multiplier, is 75%, 0.75. So and see the difference? The rate is how much you're losing. My rate is negative 25%. My factor is 0.75. That's what I'm multiplying, 0.75. So we keep that in mind, that will help us in the future. So the rate is negative 25%. The factor is 75%, which is equals 0.75.
Negative 25%?
Yeah, I'm losing 25%. I'm not gaining, I'm losing.
Oh,
Does that kind of make sense?
yes.
All right, so now we're going to work on writing some of these. And like I said, we're going to keep it nice and straightforward. You should all like this a fair amount. So let's take a look.
Hope we're not counting down the minutes.
What's that?
So we're not counting down the minutes.
Of course not, because you're having a lot of fun here.
Oh, yeah, definitely.
Like a barrel of monkeys.
I'm not sure that I would consider a barrel of monkeys fun. Kind of depends.
That's the old saying.
Yeah, it depends upon the monkeys. Capuchins, maybe.
Those,
Big angry ones, maybe not.
like those Japanese monkeys that are in those sauna, the hot springs, those are really chill monkeys.
They're nice and mellow.
Yeah.
Good.
My friend got one posing on his shoulder.
Oh.
He's stuck in Japan right now, for military stuff. He's just like, yeah, sometimes you go on tourist attractions.
Yeah, I'm surprised they let anybody move around at all nowadays. All right, so let's see. Let's go back to what we have. We have, again, some places will call it a times b to the x. I'm going to be calling it c times a to the x. The thing important to focus on is not the letters, but what they represent. You have the initial amount, that's the number in front, the multiplier, and then you have your base. That's your growth or decay factor. That's your factor. Okay, so if it grows if its base is larger than 1, right? And it represents exponential decay if the number is between 0 and 1. It can never be negative. It's going to be between 0 and 1. And this worksheet we're going to work on focusing on writing exponential models, given information about the models. So we're going to keep it nice and simple and straightforward. As you saw earlier, so you might need some scratch paper for this. Does anybody need scratch paper? I have a couple of sheets around. They're not great scratch papers, but they're pieces of paper. Can I do one of them? Do you want one too? Okay, one. Scratch paper? Oh, and if you have not gotten back your exam, get it from me after class.
Done that what?
Exam? The previous exam? The one you just took off.
Does anybody have a spare piece of scratch paper they can?
Do you want to have this? Oh, you got one, yeah. I could just have this with somebody if we're not gonna need enough.
No,
Oh,
that's not, I should have some. Ah, here. This will work. Okay. Good. All right, so first we're going to, let me go ahead and stop that. Okay, so what you'll notice is we'll have an initial amount when x is 0. And it doesn't make sense for x to be negative because we're usually talking about time, typically. But as long as we have, when x is 0, our initial amount, we have our c. That kind of gives us our first base. So here, write a function that contains the pairs of points 0, 4, and 1, 8. Find the base and then approximate the base into 3 decimals. All right, let's go ahead and take a look at that one. So first of all, if I go from 0, 4 to 1, 8, do you think that I'm growing or decaying?
growing.
Growing, because initially I have 4, then after an hour or whatever, a day, I have 8. So I've increased. Good?
Yeah, both the values increase, right?
Well, as the x's go up, do the y's go up or down?
Yeah.
Because the x's show us increase. Okay, so my initial amount c times a to the x. This again is my initial amount. And this is my growth factor. I'm just going to call it growth factor, even when it's decaying. That's fine. All right, so my initial amount here is 4. Does everyone see what I'm saying? Initially, when x is 0, I had 4 of whatever it is. So my c is what? What's c? C is my initial amount. What's my initial amount?
4.
4. So c is 4.
C is fixed. Or Y is fixed.
So far I have y equals 4 times a to the x. Now there's two different ways we can find a. The first way is substituting in 1 in for x and 8 in for y. That's the easiest way, I think. So 8, I'll put that in for y. 1, I'll put that in for x. And we will get 8 equals 4 times a to the, what's my x?
1.
1. Okay, how do I solve that for a?
Well, you can cancel out the exponential
Yep.
1.
Yep.
And make it just 4.
Right? So that's one thing I can do. So first we have 8 equals 4a. So then how do I get just a?
Divide?
Divide by
4.
4. If I divide both sides by 4, I get what?
2.
Equals
A equals 2. So I'm not going to show all the steps, like the dividing part, because at this point we should be familiar with that part. So now do I have my C? Yes. Do I have my A? So now we have our formula. Y equals C, which is what? What's C? Fill them in. Y equals what?
C is 4.
C is 4.
4.
What's A?
2.
2 to the X. Everyone check with your neighbors about this. Make sure everybody's on board. Shania, check in with these folks above you.